Hello, thanks for clicking. Welcome to another Narculus 2 production. Today we're going to be learning about sequences. Okay, so sequences are going to take us, this simple lesson here hopefully will take us and vault us into a huge discussion about our next major topic here in Narculus 2, which is going to be talking about series, which are going to be coming up in our next video. But today we're just going to work with sequences. All right, so we've worked with these before. I'm sure you have. Let's take a look. So a sequence is just a list of numbers arranged in a particular order. All right. So for example, 2, 4, 6, 8. That's a sequence. Okay. Four numbers separated by a comma. There's obviously a pattern to it. It would keep going if you wanted it to. All right. And if you wanted to keep it going, okay, instead of writing all these numbers out, you could write what's called the nth term. The nth term is an explicit formula that will yield any term in the sequence. So, for example, the nth term for the sequence above is 2n, right? So, if I wanted to find the first number in the sequence, a1, if I made n1, a1 would be 2 times 1, it's 2. If n is 2, then the second number in the sequence is 4. If n equals 3, the third term in the sequence is 6. And we can do this forever if we want using this nth term. All right? Okay, so it's a shorthand way basically to write this sequence rather than writing all the numbers in the list. All right, so what we're interested in doing with sequences is we're interested in figuring out if they converge. Okay, so a sequence will converge if the limit of the nth term, a sub n, as n goes to infinity, is equal to L, where L is a real number. And hopefully that makes a little bit of sense. The idea is the following. If you have an nth term, like let's say 2n, and that nth term can tell you any number in the list, the sequence will converge. It'll approach a finite value, the sequence will, if the numbers that are farthest away in the list, right, the numbers that 12, okay, we're not looking for these numbers here. We're looking for these numbers that are way out here, right? At the very, very, very end of the list, as far as we can go, as long as high a value as we can pick for n. And what's the highest value, so to speak, that we could pick for n? It would be infinity, right? We would just want to write this list forever and ever. So the question is, the numbers that are all the way out here, are they going to be a finite value or not? If they are, then that sequence converges. If the sequence does not converge, we say the sequence diverges. So for example, if I were to take the limit as n goes to infinity of 2n, right, the sequence on our last slide there. Well, as n goes to infinity, 2 times infinity, that's infinity. So we would say that this sequence, a sub n, this sequence diverges. What does it mean? It just means that the numbers that are all the way out here at the end of the list are going to be really, really, really large. Okay, they're going to be infinite, right? Okay, they're going to be so large that you cannot write a finite value. All right, so that's what it means for a sequence to diverge. Okay, now let's take a look at this sequence. A sub n equals 3n squared over 1 plus n squared. I want to know if it converges or diverges. Well, to figure out if it converges or diverges, I need to take the limit as n goes to infinity of the nth term, 3n squared over 1 plus n squared. All right, we need to take that limit. Here we go. So now, there's a couple ways that you can do this depending on how much you know at the time of watching the video. So what you can do first is split the two limits apart, numerator and denominator. The limit laws allow that, right? Remember that from back in the day. So as n goes to infinity, 3n squared goes to infinity, and 1 plus n squared also goes to infinity as n goes to infinity. This is infinity over infinity. Infinity over infinity is an indeterminate form. So one way to do this problem is to do L'Hopital's rule on it, right? So you derive the top and derive the bottom separate until you no longer have an indeterminate form, and then that will evaluate, and then you can evaluate the limit. Or what you could do is you could divide both the numerator and denominator by the dominant power, right? Which power actually controls what's happening to this nth term, and that would be n squared, right? The n squared is what ultimately makes the decision. So what you can do is find the limit as n goes to infinity, and you're going to divide everybody here, all of these things, by n squared. And if we clean this up a little bit, we get, up top we get 3. On the bottom, it's 1 over n squared and a 1. So now the limit as n goes to infinity. Well, n going to infinity only affects this 1 over n squared. So that's 1 over something really, really big. That's really, really small. So that goes to 0. And I get 3 over 0 plus 1, which is 3. So we would say that 3n squared over 1 plus n squared converges. This sequence, a sub n, converges to the value of 3. What does that mean? Well, that means, again, you could start writing out terms in this sequence. If you put 1 in, you get 3 over 1 plus 1, so 3 over 2. If you put 2 in for n, you'd get 12 over 5, right? You could start listing terms if you want, but I don't care about the terms at the beginning. I want to know what the terms are like all the way out here at the very, very end, as far as you can go. And what's happening is, as far as you can go, the closer you get to the end of the list, the closer you're going to get to 3. Okay, so the numbers out here at the end of the list are going to be like 2.99999999994, 2.9999999999995. All right, they're going to get very, very, very close to 3. Okay, that's what it means for this sequence to converge. It means the list of numbers eventually approaches 3 at the end of the list. Okay, all right, so let's try this one. Same idea. I want to know if this sequence converges or diverges. So I'm going to take the limit as n goes to infinity of n over 10 plus square root n. Again, I can split the limits apart, numerator and denominator. And this limit goes to infinity. This limit goes to infinity. Infinity over infinity is indeterminate. You could use L'Hopital's rule, or certainly try. The other thing you can do is you can compare these with relative rates of growth. So n would grow faster than the square root of n. So that would determine the limit. Or you can, again, divide by the dominant power. Dominant power is n, which is the square root of n squared if you're going to put it in the square root. So if we were to do that, n goes to infinity. We'd have n divided by n over the square root of, it would be 10 over n squared, right? Because that n squared is going inside the square root. And then n over n squared, n over n squared. All right, and that would be, there should be an n up top. So this is the limit as n goes to infinity. That's a 1 up there over the square root of 10 over n squared plus 1 over n. But as n goes to infinity, that's 1 up on the top. On the bottom, 10 over n squared as n goes to infinity, that goes to 0. 1 over something really big also goes to 0. But again, both of these numbers have to be positive because we're talking about a square root. So this limit approaches 1 over the square root of 0 from the right. So that's 1 over something really, really, really small, but positive. So a positive number divided by a positive number is a positive number, and 1 over something really small is really big. This limit goes to positive infinity. So we would say that this sequence diverges. It just means that the numbers that are at the end of this list are going to be so large that they're not going to approach a finite value. Okay? That's what the difference is. All right? All right, and finally, we're going to take a look at a couple of interesting sequences. So here's a couple of interesting sequences. A sub n equals -1 to the n. And we're going to see these concepts here that we're looking at. And n, which is the excited n factorial, or n factorial. So these sequences, if we write out the terms, if a is 1, we would get -1 to the 1, which is -1. A2 would be -1 squared, which is 1. And you can see quickly what happens. -1 cubed is -1 again. -1 to the 4th is 1 again. So the sequence looks like this. It just looks like an alternating set from 1 to -1. -1, 1, -1, 1, -1, 1. And that would continue forever. Okay? Now, if I were to ask you if the sequence converges or diverges, well, the question is, does it approach a finite value? So if you were to take the limit as n approaches infinity of -1 to the n, the answer to this question would be no, it does not approach a finite value because it oscillates between two finite values. It just keeps going back and forth. It's -1, then it's 1, then it's -1, then it's 1, then it's -1, then it's 1. So it doesn't approach an actual finite value. Okay, so this limit oscillates. So that means this sequence diverges. And the other sequence, that's an interesting sequence that we're going to work a lot with, is n factorial. So if you remember, if I plug in 1, that's 1 factorial, that's 1. A sub 2 is 2 factorial. That means multiply 2 times 1, and you get 2. If I plug in 3 factorial is 3 times 2 times 1, right? That's 6. If I take the fourth term, that would be 4 times 3 times 2 times 1. So that's 12 times 2, that's 24. So my list of terms of this sequence would be 1, 2, 6, 24. And then I'd go on from there. So hopefully you can see, just by looking at this thing, that the higher number you plug in, the larger the value is going to be. And when you get to values like you're talking about, even 100, okay, that number is going to be very, very, very large. And as n goes to infinity, again, this sequence would diverge. All right. And that's it for sequences. Okay, that's a look at some simple sequences. We're going to use the concept of sequences in our next video to talk about the series. As always, thanks for clicking.